Hello, welcome to this video, and in this video we'll be looking at the concept of negative and positive work. So let's begin with what work is. We know by mathematical definition that work is the product of force and displacement. So this is the definition of work. I can write that now in mathematical formula. Let me use this letter W to represent work. This is going to be the product of force and displacement. So we have force, okay, and then displacement. Now, as you know very well, force is a vector quantity and displacement is a vector quantity. And from the idea of multiplication of vector quantities, we have two types of multiplication. We have the scalar product and we also have the vector product. So this is a multiplication between two vector quantities. So we have to know what kind of multiplication we are doing exactly. And this is going to be scalar multiplication because work is a scalar quantity. Work is a scalar quantity. So in that case, the work done is going to be the product of force as a vector times displacement as a vector. Okay, in that case we have the scalar product. That means we can just create more space here. So that basically means nice, work is equal to the magnitude of force times the magnitude of displacement times the cos of the angle between the two vectors, the force and the displacement. So when do we say that work done is negative or the work done is positive? Let's use this mathematical definition of work to explain how that comes about. Let us consider a surface, and we have an object lying on this surface. Let's assume we are applying a force in this direction, F A. So this is the applied force. That's the applied force. Then friction is acting in this direction. Oops. So we have friction. Now let's say the applied force is greater than friction, and so our body is moving in this direction. This is the direction of motion. Let's take a look. As we continue to apply our force, this body is going to be displaced somewhere in this direction. So the displacement is actually heading to this direction, since that's the direction where our motion is heading. Okay, now let's try to see which of these two is doing negative work and which one is doing positive work. The applied force and the force of friction. So let's examine the two forces, beginning with the friction force. So the friction force, in this case, the work done by friction, that's going to be the magnitude of friction force times, okay, the magnitude of friction times the magnitude of displacement. Okay, this is the displacement S. So times the magnitude of displacement times the cos of the angle between the friction force and the displacement. As you can see, the frictional force and the displacement, there is an angle of 180 degrees. So that's cos 180 degrees. What's that going to be? Whatever the values of the magnitude of F and magnitude of S are, this is going to be -1. So this is going to be a negative value. That means, if we are to conclude here, friction does negative work. Friction does negative work. Let's examine the kind of work that our applied force does. So the work done the work done by the applied force so in that case it's going to be equal to the magnitude of the applied force times the magnitude of displacement. The angle between the applied force and the displacement is actually 0, so that will be cos 0, and we know that cos 0 is 1, so I'll have magnitude of the applied force times magnitude of the displacement. So what is important here is that the work is positive because cos 0 is positive 1, so we conclude that the applied force does positive work. Okay, so what's the difference between these two forces, the applied force and the friction force, in terms of the displacement they offer? Let's make a general conclusion here. It's very important that if the displacement, okay, if the direction of the force and the displacement caused by the force are opposite, then the force does negative work. Otherwise it does positive work. So if the direction okay, so if the direction the direction of the force and displacement are similar or are the same, the force does positive work. So as you can see in our case study here of friction and the applied force and the displacement are actually in the same direction, so the applied force does positive work. The friction and the displacement are in opposite directions, so friction force does opposite work. The concept of the sign of work done is very important because it helps us to know whether the displacement caused by the force was actually in the same direction or not. Let's have another quick example here about electrostatic forces. Suppose we have a positive charge A and another positive charge B. Okay, it's also positive. Suppose we try to move the two charges together. So we are applying a certain force Fa to bring the two charges together, but from the laws of electrostatics, the positive charge A and the positive charge B will repel each other, so another force is actually acting on it, and this is the electrostatic force. Let me call that Fe, which is opposing the force from the charge B from coming this side. So let's examine which of these forces is positive and which one is negative. Okay, because we are applying our force now, the force that is doing positive or negative work depends on which force is having the greater impact. So let's assume Fa is greater than Fe. So in that case it means the applied force has greater impact on the motion. That means consequently the motion is in this direction, and so the displacement is also in this direction. So as you can see, since the force and the displacement for the applied force are in the same direction, the applied force does positive work while the electric force, which is caused by the electric field due to A, does negative work, because the displacement and the electric force are actually in different directions. You may recall, perhaps from electrostatics, that the work done is always negative. The electric potential due to a charge is given by negative E dx, something like that, or if you recall, E equals negative dv dx. That's how we come to have this negative here, because the electric field is opposing, yet the displacement is actually towards the charge that is opposing. Okay, that's it about positive and negative work. If you have more questions about this or comments, please leave them below. Also, help me grow this channel by liking this video, subscribe, so that I can grow this community and make better videos. I make content for physics and mathematics for both high school and college. Thank you.